So here again, you have a function, and on the screen you can see that you also have the graph of the function. So from the graph we can see that x equal to -1, the value of the function will be maximum. It is equal to 2. And at x equal to 1, the value of the function will be minimum. It is equal to -2. So -1 is therefore called as a point of local maxima, and x equal to 1 is called as a point of local minima. So from the graph, learning all these points, it seems like it is not so difficult. But what we will do is, we will not use the graph to find out all these points of local maxima or minima, or maximum value or minimum value. But what we will do is, we will use the first order derivative and especially the second order derivative to find out all these points. So how to do that? Here we start. So you have a function f of x equal to x cubed minus 3 times x. So from the notation you can understand that f of x means the function is having an independent variable x, or the function is depending on x. So what we do is, we differentiate both sides with respect to x. And when we do that, we will write f prime of x, and you'll be getting 3x squared minus 3. Now, since we are going to use by the second order derivative test, what we do is, we differentiate again from the first derivative that you have already got, and so f double prime of x will be equal to 6x. Now, we know that at those points on the graph where the function or the graph is having a maximum value or the minimum value, the tangents at those points will be parallel to the x-axis. And whenever they are parallel to the x-axis, f prime of x is equal to 0. That means slope of those tangents which are parallel to the x-axis are always 0. And when you do that, you'll be getting x equal to 1 or -1, because f prime of x is equal to 0. That is 3x squared minus 3 equal to 0. So by putting f prime of x equal to 0, we have got x equal to 1 or x equal to -1. These are now called as critical points. We cannot call them as point of local maxima or point of local minima, because we don't know yet what will be the value of the function at 1 and -1. But to know that, we will use a second order derivative. So let us first of all take x equal to 1, one of the critical points, and substitute x equal to 1 in the expression of f double prime of x. So when we do that, what we will have to check is the value that you get. If it is greater than 0, whenever you get a value which is greater than 0, in this case and always, we say that x equal to 1 is a point of local minima. Greater than 0, we call it point of local minima. And we now understand that x equal to 1 is a point of local minima. Why? Because the second order derivative test tells us that it is a point of local minima because you have greater than 0. F double prime of 1 is greater than 0. Now, therefore, the minimum value of the function will be f of 1. We simply put the value of x equal to 1 in the given function, and therefore you'll get minus 2. So that is all about point of local minima and the minimum value of the function. Now let us see at the second critical point, that is x equal to minus 1. So putting x equal to minus 1 in the expression of f double prime of x, you'll find that you get a value which is minus 6, and this is less than 0. So whenever you get less than 0, always we should understand that x equal to minus 1 is a point of local maxima. Less than 0 means point of local maxima. And therefore, the maximum value of the function can be found out simply by putting x equal to minus 1 in the expression of the given function. So f of minus 1 will be equal to 2. So that is using the second order derivative, and the steps will be always same in all the problems that you'll be attempting. So first of all, what you have to do is make sure that you can understand all the steps that you have gone through, and remember to follow these steps, and you'll surely solve all the problems.